Welcome back, ladies and gentlemen. As you can see, we are about ready to begin distance. Hopefully that first video uploaded well and you guys are easily able to understand it. But right now, we have gone through an overview, but now we go into some detail. Make sure you turn to page 5 of your booklet. Now, distance is, of course, as we've already discussed, one of the possible things that we will be looking at. It's one of the scalars, and right off the bat, that's what we're going to write about. We're going to say distance is that first blank, and as it tells us, distance is the amount of space between two objects. Now, on the far side there, this got a little bit of a blank, and we're looking at it being a scalar. So we can circle that. So distance should be fairly familiar. You walk that every day when you come to class, or you go to your locker, or you visit with friends. Distance is just moving through space, right? The distance from me to the pencil case here is only about 50 centimeters. Units, we're going to be looking at meters or kilometers or kilometers. Both work. Now, when it comes to units, and then of course the symbol, which we're going to be putting down over here, and that's just D. No arrow, no bold, nothing like that. Now, the units, kilometers or meters, it depends what we're talking about, right? If we're talking about something small, we're going to use a meter. If we're talking about something large, we're going to use a kilometer. If we're talking about something really large, we're going to start using astronomy, and we're not getting there. Next, we've got a box, and in here we're going to write down our distance formula. So this is going to be our formula, and there's sort of two ways to write this, depending on how comfortable everyone is with mathematics. So the first one is that the total distance is equal to the first distance plus the second distance plus the third distance, and you just keep going. So basically what I'm saying is that the total distance you travel, you add all the distances. That's it. That's all you have to do. Now, this is one way to write it, and totally accurate, 100% correct. You can use this way to write it, and it will not be wrong in any way. However, some people want to go a little bit further. Instead of writing D total, the other thing you can do is you can write it like this. Now, you'll notice that this back half is the same the whole way through, right? This and this are the same. Here's the only real difference. And then the only real difference that we're seeing is this early symbol that I've scribbled here. Now, this is Greek, and it's used when it comes to math. They use it to explain certain things. So this symbol is called sigma. This is the capital version. I usually end up using a sort of a lowercase version that ends up looking more like a Christmas tree, I'm told. And the thing about sigma is that it means sum or add all. And if you notice, that's actually what we did here. We added all of the things, and that's it. That's all we have to do. So when it comes to doing any kind of distance calculations, this is sort of the starting point that we're going to deal with. Now, there should be some blanks just below there where it talks about that sigma symbol. So sigma, and it means the sum of, as in the sum of the distances is equal to the first plus the second plus the third. So we'll just quickly fill in what those blanks were. I'll stick it over here out of the way. So we've got sigma. We've got sum of first, second. Those are the last few blanks that you guys can see at the bottom underneath the box. Now, at this point, we've got some calculations for you guys to try here. Find the distance between these 2 points. Number line kind of stuff. Hopefully, you guys have had a lot of experience with this. You guys are being pretty practiced, and hopefully that part by itself won't be too hard. You guys have been doing it for a while now, after all. Now, Now would be a great time to pause the video, go through, try some of the questions, but here we go with the answers, just in case. First set of questions. What is the distance between two numbers placed on a number line? So you've got 4 and 10. Well, if we were to draw a number line, here's 0, over here will be 10. And we'll put 5 in the middle here. So here we go, we got 6, 7, 8, 9. And here we've got 4, 3, 2, 1. So we're going from 4, do that in another color, to 10. Here's the other ending. So 1, 2, 3, 4, 5, 6. This is a distance of 6. There's something missing. It's not just distance of 6. Normally we would say distance of 6 meters. Now that's assuming that we were dealing with meters, but in this case it's actually just a number line, so there's no meters involved. So we can just leave it as 6, but in most cases you're going to need units, so make sure you include them. Next question. We've got -2 and -8. Negative signs, of course, immediately make things a little bit tricky, at least for some. Depends what you're comfortable with. So once again, we're going to draw the same number line, but since it's negative, we usually make negative left, so I'm going to make this side -10, and over here, 0. There we go. I'm going to need to divide it up again. You'll notice that I kind of do it by cutting it in half first. It makes the problem a little easier. That's generally true with things. If you cut up the problem into smaller parts, it's usually easier. That works for physics, that works for drawing lines, that works for completing whatever assignment you have to do, just about anything. What it doesn't work for is when you're not paying attention and then you do everything wrong. 9, 8, 7, 6, 4, 3, 2, 1. There we go. All right, so we're starting at -2 right here, and we're going to -8, which is right here. 1, 2, 3, 4, 5, 6. D equals 6. So these two questions actually have exactly the same answer. It is 6 steps for both of them. So let's try the next one. And we're going to be looking at C, which is -12 and -3. Once again, we map it out. Zero. There's the -12. And we're going to be starting off at -3. 1, 2, 3, right here. And we're going here to -12. So we're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is D equals 9. Let's continue with the other few, and we'll do it with mathematics. D. We're going to have +7 and -3. Okay, so we're starting at +7. And then we are going to -3. Well, 7 to 0 would be 7. So that's going to be at least 7. And then I'm going to take 3 more steps. So that's going to be 10. E. -12 and 12. Well, 12 to 0 is 12. 0 to -12 is also 12. So this one is just going to be 24. Okay. I'll leave number 3 for you guys. Let's take a look at the example at the bottom of the page, though. This example has got a framework around it, something that you guys can try to use when you're trying to work through some of these problems. What you're going to find is that a lot of this stuff is actually not too bad if you keep organized. The hardest part is when students are stuck with what I call the rainbow of math, where, you know, the math starts somewhere over here and then continues somewhere over there and then eventually comes back over here at some point. It gets messy, to put it mildly, and that messiness causes a lot of trouble. So this is a way that we can organize things. It says here that you're going to walk 1,000 meters to school, 50 meters to the store, and 80 meters to the school parking lot. What is the total distance that you walk? Show your work. So this is broken down into sections. You've got your given, then you've got your formula, then you've got your calculation, and then finally your answer. These are the steps that you're going to need for every single problem. No matter what happens, that's what you're going to be dealing with. So, given, what does the question give you? All right, you've got a particular distance, which in this case is 1,000 meters. Then you've got another distance. This particular question, it says 50 meters. Then you've got another distance, and it says that one is 80 meters. Okay, 3 distances. Next, what formula do we need to use? Now, obviously, your notes are right in front of you. You don't need to look up the formula. Not really. I mean, we've only had one. Almost anybody can remember one formula. But later on, we're going to have more than one. And it's useful to be able to keep track of these things. Now, before everyone asks, obviously, you're going to have formulas on the test. I'm going to give them to you. You don't have to worry about memorizing them. But if you write them down on a regular basis, you won't have to worry about memorizing them no matter what, because it'll already kind of be in your head. Makes things a lot easier. So our formula, I'm going to use the sigma form, D1, D2, D3. It's literally 3 in this case, so I don't have to go any further. Normally, right, if there was 4, 5, 6, I would have to add another D, another D, another D. Not in this case. Then I do the calculations. This is where I take the numbers in the given and I plug them into the formula, and then I write all that down. So that means that sigma D, which remember sigma means the sum, the total, is equal to 1,000 plus 50 plus 80. Now, some of you are looking at that going, okay, I already knew that. Why am I writing all this down? Again, later it gets more complicated, so you're doing this to get used to it. So at the end of the day, you've got your final answer. What are you going to get? Well, now's when you get to find out Mr. C's not great at mental math. But let's see. 8 and 5, that's going to be 13, so that's going to be 130. So that means this is going to be 1,130 meters. And that's our final answer. We could, to be very accurate, go that the sigma D equals all of that, just to say, you know, putting it all together, there it is, all in one place. But that's it. That's how you put this together. Hopefully, pretty straightforward. Now that's it for distance. If you flip over the page, you're going to see time. Time, he says. You know time. Time is familiar to you. In point of fact, time is so familiar to you that you don't even understand just how much you know about it already. What is time? Well, first things first, time is the passage of moments from the past to the future. And unless one of you is a time traveler and you haven't told us yet, as far as we know, you can't go backwards in time, although it makes for good movie plots. It is, of course, a scalar. You can circle scalar. Time is all around you and constantly advancing. There are 2 ways to talk about time. Now, this is the part I'm going to say some words and you're going to be like, huh? You already know this. The 2 ways to talk about time are instantaneous and interval. Now you'll notice there's some examples underneath. Instantaneous. The example, which I'll write up here even though you guys have it and I don't, the example here was 2:15 p.m. A wonderful time because we're almost at the end of the day, or at least a normal day. Then we've got interval, and the interval example is stuff like 5 minutes. What does that mean? Well, we'll see. We've got some examples we'll work through. The units for time are going to be seconds, minutes, and hours. So this is the units. And again, a reminder, normal scientists, under most circumstances, will just use S for seconds. I'm using SEC just to make it a little clearer. Obviously, you're familiar with these units. I feel like you know them already. The symbol is the last piece of the puzzle. We already talked about that. The symbol is T. Now, once again, we've got ourselves our box with our formulas. Now, our formulas have got some interesting patterns to them, right? Things we already have seen. Old faces. The first formula that it's going to talk about there is going to be sigma t. Now, sigma, remember, means add. Add everything. Well, if we add all the times, we're going to get t1, t2, t3. This is the sum of time, right? I'm adding all the times. Now, this isn't the only thing we can do. We can also talk about an interval of time. Now, an interval of time is from one time to another. So usually the example I do is this, right? Class ends, if we're lucky, 2:15. Great. Let's do an even more fun thing. School ends 3:30. Back in the day when school ended at 3:30. I know, you guys are still working. Let me guess. Some of you, it's probably like 10 at night. So, 3:30, school ends. Class starts at, say, 2:18. Those are instants of time, instantaneous time, right? 3:30, class ends, the bell goes, you can leave. 2:18, class starts, if it's the last class of the day. An interval of time is this. How long is class? And you stop and you go, oh, well, I have it down to the second, don't I, right? It's going to be just over an hour. Hour and 10. That's an interval. And you know it's an hour and 10 because you take the final time, 3:30, and the starting time, 2:18, and you compare the distance between the two. That's an interval between two. So when you're trying to calculate an interval, you're going to do a slightly different kind of equation. Calculating an interval is going to be this equation. And you may recall seeing this triangle in the previous lesson when we were talking about the thing called displacement. So here it is, it's shown up. Well, what does it mean? Well, right underneath the box, we're going to fill that in. That triangle is another Greek letter. It's a holdover from math because it turns out that physicists like math too. This triangle is called delta. Delta has a meaning. Just like sigma means sum, delta means change in. So what do we mean by change in? Well, just like we were talking about with the how do we know when the class ends, final time, that's what the F means, final, minus initial time. That's how we do it. So this final time here, which is one of those blanks here, final and then initial is the other blank, is how we work out the time between two things. Now, we always got to be careful, right? Because, well, let's use the example that we've got here, right? End of the day. Our final time would be 3:32. Our initial time is 2:18. 3 minus 2 is going to be 1. 32 minus 18. Again with the Mr. C, not good at mental math. But let's see. 32, 18. Bring 1 over 2. This is going to be 1. 8 to 12, 4. Is that about right? So that means it's going to be 1 hour and 14 minutes. That's how long class is, apparently. That's the interval. That's how we did it. The part that always confuses students when they're starting out is that they're always like, what do you mean the initial time is the second one? What? Like, initial means first, so why isn't it first in my equation? That's just kind of the nature of how the delta works. The delta is about where am I ending, and I'm going to subtract the beginning from that. Yeah, it's a little weird, but don't worry, you'll have lots of chance to practice. Yay. Now obviously we've got a little bit of a problem here also because I've got hours and minutes. And those are two different units. So at this point I'm going to talk a little bit about conversions. You'll see I have another box with another formula in it. So when it comes to conversions, let's get some board space. When it comes to conversions, we're going to be dealing with some interesting little problems. Often we're going to have to convert from one unit to another. And the way that we do that is kind of dependent on how we're trying to approach things. So the formula that you guys have in front of you works for pretty much everything. Have, want, lose, gain. Now how do we use this? Okay, so let's use an example here. We were just talking about hours and minutes. Let's do that. So let's say I've got, let's see, 3 hours. That's what I have. And I want that answer in minutes. Now, you guys, again, pretty familiar with time. You're pretty comfortable, and you're going, I can do that in my head. It's no problem. Your mental math skills might not be great, Mr. C, but mine are amazing. That's fair. But let's make it a little bit trickier. Minutes? Fine. Anybody can do that. We're going to do seconds. How many seconds in 3 hours? And suddenly everyone goes, that's useless. I don't know how to do that. It can't be useful. But we can do it with this method. So we take some brackets. We go like so. Lose goes on the bottom. What do I want to get rid of? I don't want these hours. Right? I don't want them. I want them gone. So hours are going to go on the bottom. And what do I want to get, to gain? I want to gain seconds. Okay, so I put seconds on the top. Well, by itself, this doesn't do anything for me because I don't have any math yet. But here's where the trick comes in. Here is where I put together the conversion factor, or what they're related by. Put another way, 1 hour is how many seconds? Well, there's 60 minutes in an hour. There's 60 seconds in a minute. So I could grab my handy calculator if I don't remember, or you can use your phone, unless that's what you're currently watching this video on. And I can go 60 times 60, and I get 3,600. I know it's not a nice round number, but unfortunately the Earth doesn't work by decimals. And here, I now see how to do my conversion. 3 times 3,600 divided by 1 will give me my answer. So I just go times 3. And I'm going to get 10800 seconds. And this is one of those weird things about time and people. Humans are not good at telling time. That's why we have machines to do it for us. Watches, clocks, cell phones, GPS, whatever. if I ask somebody 10,000 seconds, how long is that? Most people will think, well, it's a long time. It's half a school day. It's really hard for us to keep track. You can ask someone, how long is a second? And they'll be like, it's about that long. Okay, how long is 10 seconds? They'll be like, well, it's like that long, maybe? What's 1,000 seconds? Well, I don't know. 10,000 seconds. What's 1,000,000 seconds? 1,000,000 seconds sounds like an awful lot. Right? Like 1,000,000. Oh, 1, 2, 3. 1, 2, 3. There it is. 1,000,000 seconds. I don't know what that is. You don't know what that is. But we can find out. We can convert it. So let's do that. We got seconds. Let's turn it into hours. Right? Have seconds. Want hours. Okay. Then we put our brackets. Seconds I want to get rid of, so they go on the bottom. Hours go on the top, because I want to get them. Now I got to fill in the numbers. This is the part I have to remember. 1 hour, we just said, was 3,600 seconds. Now you'll notice this one and this one look different. That's okay, that's normal. Notice the design of the formula. What I want to get on top, what I want to get rid of on the bottom. I wanted to get rid of seconds because I had those already. And I wanted to get hours, so I put those on the top. Now the eagle-eyed in the room, well, on their phones, who know algebra might see what's going on here. The rest of you, don't worry about it. So it's no problem at all. That's why I'm showing you this formula. So I take my 1,000,000, and I'm going to divide it by, multiply it by 1, and then divide it by 3,600. And that's going to give me 277.7 hours. That doesn't seem very helpful, does it? Like 277 hours? What does that mean? Well, that's okay. We can convert it again. We've got 277.7 hours. Let's make that days. Suddenly things are getting a little more complicated. Same setup. I want to get rid of hours. I want to gain days. Well, 1 day has how many hours? Now I ask this, I of course know. It's 24. But you'd be surprised. Sometimes I ask the grade 11s that in physics, and they'll get stuck. They can't remember. Then we have a good laugh about it. So I'm going to take my calculator again, because my mental math isn't good enough to do this in my head. And I'm going to multiply by 1 and divide by 24. And that gives me 11.5 days. And now that is understandable, isn't it? 11 days, almost 2 weeks. That you go, oh, yeah, okay. Think, that was 1,000,000 seconds. And when I first said 1,000,000 seconds, you probably thought, oh, that must be years. Oh, it's not even a half a month. So again, humans are not good at telling time. That's why we have things to tell time for us. Anyway, you have now seen how to do conversions. You can now attempt some of the various calculations that you see on the page in front of you. Give those a shot, and I will see about collecting some answers to post online for those. Okay? Now, if we take a look at what's coming up next, we see that it is speed. That will be a good start for another video.